Hey guys, Miss Miklos here with our second lecture of this particular chapter. And today we're going to learn the second method that we can solve, and this is solving by radicals. So before we begin solving by radicals, I just want to review what radicals are once again. And this is definitely an Algebra 1 concept that I am assuming you guys already know. So today is just a review of it. It's not teaching new material on this. So if we look, I have a giant radical, and some of you might be thinking, well, why is she calling it a radical? That just looks like a square root to me. And to be more specific, a square root is a specific type of radical. However, as you notice, I labeled some things here. We have a number inside here. We call that our index number. We are very used to seeing nothing here. When we don't see a number there, we know automatically our index number is 2. And that means that it is a square root. Today, we're going to work with some index numbers that are different than 2. Later on this year, we're going to work a lot with cube roots and fourth roots and fifth roots and so forth. Obviously, this is what we call our radical sign. And our number inside our radical, we call our radicand. It's a fun word, radicand. And we have 3 basic rules about simplifying radicals. Number 1, no groups of the index number can be left inside. So what that means, if my index number is 2, I can't have a pair of numbers inside our radical. If our index number was 3, I couldn't have 3 numbers inside our radical that were the same. And we'll explore that as we simplify. Second rule, I can never have a fraction under the radical. If I have a fraction underneath, I need to apply the radical to the numerator and to the denominator. Lastly, we can never have a radical in the denominator, so if we have that, we need to figure out how to get rid of it. Okay, so we're going to go through a very basic simplifying problem. There's a few different methods that you may have learned to simplify radicals. I personally prefer to use factor trees because that is very consistent for no matter what the index number is. Here, since I do not see an index number, we know that it is 2. So when I make a factor tree, I need to think, what factors multiply to be 24? And there's not a wrong answer if they multiply to be 24, other than we don't want to have 1 and 24 in there. So we want to break it down. So I'm going to go with 6 and 4. I know I can break 6 down further into 3 times 2, and I can break 4 down further into 2 times 2. You will often hear this regarded as prime factorization because we took a number and we broke it down into factors that are all prime numbers. So now what we need to do, since our index number is 2, I need to look and see, do we have any pairs of numbers? And I notice that I have a pair of 2's. So I'm going to write that on the outside of my radical. So I always put my pairs outside. If I had more than one of them, I would multiply them together. Whatever's left over, so 3 times 2 is going to go inside, and I'm going to multiply those together and get 6. So our answer here would be 2 radical 6 or 2 root 6. We could say it either way. Okay, so number 2, if I'm doing a problem like this, instead of actually multiplying 6 and 15, I'm just going to write this as radical 6 times 15. Okay, I can multiply radicals together if we have the same index number. The reason why I didn't actually multiply them together is because if I want to make a factor tree anyways, why would I want to undo that process? So I'm going to break this down. I know 2 is 3 times 2. 15 is 5 and 3. Once again, my index number here is 2, so I'm looking for pairs. And I notice that I have a pair of 3's, so I'm going to write the 3 on the outside. Inside I have 2 times 5, so I'm going to write 3 radical 10 as my answer. Okay, for number 3 here, we have a slight issue because we know that we cannot have a radical underneath we cannot have a fraction underneath my radical. So the first thing I'm going to do is split this up and square root the numerator and square root the denominator. So I'm going to look in the numerator first, and there's actually nothing that I can do with 7, so it's going to stay radical 7. If I look at 16, some of you guys should know that off the top of your heads, but it is 4 times 4. I realized we could break this down further, but since I have a pair already, I can just stop, and my answer here would be radical 7 over 4. Okay, so this is probably the toughest one we're going to deal with. When I have 15 over radical 3, I have a problem because we cannot have radicals in the denominator. So, some of you guys would think, oh, well, let's just square it and that'll get rid of the square root. Well, if this was an equation, that would work great, but I don't have an equation here. I have an expression. I know the only thing I can do to an expression is multiply it by 1. So I need to figure out what would I need in order to get rid of the radical. Well, we already learned that if I have a pair of something, we can take things out of the radical. So since I have a 3, I need one more 3. So I'm going to multiply the numerator and the denominator by radical 3. So in my numerator, I get 15 over radical 3 over radical 9. By the way, eventually I would hope that most of us could see this and just write what the square root of 9 is, which is actually 3, but I'm writing every step out here. Lastly, I can simplify the 5 and the 3 because these are both numbers outside of a radical. I cannot simplify numbers like this because that 3 is inside the radical and this 3 is not. So when I simplify, this becomes 5 radical 3. Okay, so key thing here is I need to figure out what will help me get rid of my radical in the denominator. It's completely fine to have a radical in the numerator. We just need to get rid of whatever is down below. Okay, so now we're actually moving on to what our problems are mostly going to look like. Where I am solving, I can tell we're solving because we have an equal sign. So I have 2x squared plus 1 equals 17. And so I am going to solve this using a square root. So there's a few things that we need to think about. So the first thing you might think about is why would we use solving with square roots on a problem like this? And the big thing is that we have no x value. I have x squared and I have constants. So that would be just a good signal to me that using square roots is going to be a good method. What we need to do to begin with is isolate our x squared. So I'm going to subtract 1 from both sides, and then I'm going to divide both sides by 2. So I get x squared is equal to 8. Now I know that in order to undo a square, I need to do a square root. And the thing that I need to remember is whenever I square root a number, I need to remember plus or minus. So I'm going to write the square root of x squared equals plus or minus the square root of 8. And once we get to our answer, I will further expand on why this is true. So I get x equals plus or minus. If I'm looking at 8, I know this is like 2 times 2 times 2. So I have a pair of 2's that I can take out and 1 2 that is left over. So my answer is plus or minus 2 radical 2. Now it makes sense that I have 2 answers here because it is squared. If I just got one answer, I know that I am wrong. Also, we know when we square values, when I square a positive or when I square a negative, if that negative is inside the parentheses, these would both be equal to 8. So that's why when I square root 8, there are 2 different values that can make this a true statement. Okay, number 2. Number 2, once again, is a problem I think is the easiest to use square rooting with. The reason, once again, all I have is a squared term and constants. I don't just have a phantom x that is not going to be squared because this x is inside the quantity that's being squared. So first thing I need to do here is isolate whatever's being squared, and I would do that by multiplying both sides by 3. Now this one's a little different than our previous problem because I'm not isolating x squared, I'm just isolating the quantity that is being squared. So at this point, I'm going to square root both sides. I need to remember to put my plus or minus out in front. So I get x plus 5 equals plus or minus radical 21 because there's nothing I can do to simplify that. Now I am not done yet. To get x by itself, I would need to subtract 5. So my answer is going to be x equals negative 5 plus or minus radical 21. So I just want to point out that on a problem like this, we always write the number first, then plus or minus the radical. Once again, I have two different answers. I have negative 5 plus radical 21. I have negative 5 minus radical 21. And since this is a squared equation or a quadratic equation, it would make sense that I get two solutions. Okay, our last example. Once again, I don't have an x term, so I need to isolate whatever's being squared. So I'm going to start by subtracting 3 from both sides. So I get negative 5x squared equals negative 12. I'm going to divide both sides by negative 5. So I get x squared equals 12/5. Those of you that love decimals, you're going to have to do it my way this time because it is really important it's written as a fraction in order for us to simplify this properly. I know I'm going to square root both sides, and all of a sudden I have a problem. I actually have two problems here. First of all, I know that I cannot have a fraction underneath our radical. So I really have plus or minus the square root of 12 over the square root of 5, which I know is actually 2 radical 3 over radical 5. Because if I broke down 12, it would become 2 times 2 times 3. Now this cannot be my final answer because of this radical 5. So in order to get rid of the radical, just like we did in our previous example, I'm multiplying the numerator and the denominator by radical 5. So I get plus or minus 2 radical 15 over 5. I need to look and see, can I reduce 2 over 5 at all? And we cannot, so this is our final answer. So this method of square rooting is the other method that I think is easy and quick. Unfortunately, just like factoring, we cannot use it every single time, hence why we need to learn our other two methods of solving.